Alright, welcome back. We start a new lesson today, generative deep learning. And generative deep learning, I would say, reveals the creative side of machine learning. Creative side of machine learning. Yeah? Because we will try to create things. Now, what will we create? Well, you have sequential data like music and text, or you have image data. Yeah? And basically what we're going to do is learn the statistical structure of that data. And once we have the statistical structure of the data, we will try to predict the next point, right? In music or text. In text it would be the next character or word. In music it would be the next note. Yeah? So that is what we're going to try to do. So in terms of text, in lesson 17 we discussed LSTM and GRU in detail. So basically you're gonna launch a GRU on a text so that it can learn the model parameters. And now this model, after training, is able to predict the next character in the cat GU. Yeah, so should be able to predict that character. So basically we're gonna sample from the distribution and try to make predictions on the next character. Now we know that the output or the prediction or the potential prediction of the next character is gonna be a softmax. And in this softmax you're gonna have a list of possible choices with their probabilities. Yeah, it will be something like this. I would call it the true distribution. You have GU, M with the highest probability. So basically here what you will do is you will select M. Yeah, this is very clear because M has the highest probability. Alright? But there's other options. Yeah, there is an option where we would do greedy sampling. Yeah, here you have basically you only look at the U in front of the M. So I'll take the J away, and you're gonna check what is the most frequent character that comes after a U. And if this is an M, you're gonna select M as well. Yeah? You're gonna select M. No matter what the characters are in front of the M. Yeah? And also no matter what the characters are, if you do a bidirectional GRU or LSTM, you come from this side. So you purely look at the previous character. This of course gives a problem because every time I have a U in my text, it's going to be followed by an M, and it is not likely to give me a good language or a language model. So that's one extreme. The other extreme, of course, is that you give each character an equal probability. So the chance that it is M, S, G, Q, or whatever are all the same. So here your outcome will be, I don't know, yeah? It could be anything. So that's the other extreme. So between this and this, we define a hyperparameter called the softmax temperature. And the softmax temperature will allow us to have more randomness. So on this side is more randomness or less randomness to the left. Yeah? So by choosing this parameter, we can make that choice. We're gonna use a coding exercise or do a coding exercise where we do character generation on a text by the German philosopher Friedrich Nietzsche. These texts are quite heavy. I read a few books of Nietzsche in my younger days. Ecce Homo is a popular one, and also Also sprach Zarathustra is another one. So we're gonna train our model on the Friedrich Nietzsche text, so it's gonna have Friedrich's footprint in it. And then we're gonna decide how much randomness we want in order to generate new text.